Hello, my name is Nigel Griffiths. I work in the Advanced Technology Centre in the UK, which is part of IBM Europe. In this Back to Power Basics collection of movies, this one starts off with the introduction to power systems, and in particular we're going to look at logical partitions and virtualization. In later movies we'll go into more details of each of the subjects introduced here. First I'd like to show you this graph that's taken 12 years to actually create. I've taken the fastest machine available in the power range of computers for the past 12 years. You can see the dates along the bottom here. And I've plotted against that the relative performance number, the RPerf number, to give us an impression of how much faster these machines actually are. And here we have the winning machines for each of those years. We start off with the S70, which is an RPerf of 2. Now that looks pitifully small on this graph, but it was actually a very fast computer in its day. Then we run up through the Power 4, Power 5, and now the Power 6 machines. And the Power 6 595 this year is rated at 550 RPerfs. We can see this is an enormous growth in the power of these computers. This performance growth is actually 260 times over this 12 years, which is quite impressive. Now let me explain the color coding on this graph. The initial 4 years were based on a machine based on this Power RS-64 chip, and the computer ran as a single image, a single operating system running one or more workloads. But in 2001 we introduced the Power 4 based machines. This gave us the logical partition technology, and shortly afterwards the dynamic logical partitions, where we could change these logical partitions with the operating systems still running. In 2005 Power 5 was introduced, and this added two more technologies: shared processor partitions, where we could allocate a logical partition less than a whole CPU, and we had the virtual I/O server. Now these four technologies we're going to look at a little bit more detail in this movie, and we'll go into a lot more detail in other movies. In 2007 and 2008 the Power 6 based machines were introduced, again with even more technology for virtualization. These topics are covered in other movies, so I recommend you look at those other movies for Power 6 and AIX 6 technology. Let's have a quick look at the current Power 6 range, as there's an important point I want to make in a moment. At the low end we have the blades, the JS12 and 22. They fit into the IBM Blade Center. We can have 14 of these in a particular Blade Center. Then we have the entry machines. These are either desk side or they can go into a 19-inch rack, the 520 and the 550. They can also have extra I/O drawers to provide extra adapters. In the mid-range we have the 570 machine. Again, it can have extra I/O drawers for more adapters. And at the enterprise level we have the 24-inch rack machines, the 595 and the 575. If we look at how many cores or CPUs these can hold, in blades it's between 2 and 4. In the entry machines it's up to 4 and up to 8. For the mid-range we have 4 to 16. The 570 comes in a 4U unit, and you can even add extra units to increase the power of the machine. The 595 then is a Top Gun machine, and we saw the performance rating of that machine on the earlier graph. The 575 is a machine that's used for high performance computing. It allows us to have 14 of these in a single 24-inch rack. That gets us up to 448 cores in a single rack. All of these machines will run the operating systems AIX, IBM I, and Linux for Power. We can dedicate the whole machine to a particular operating system, or we can have any mix and match of these operating systems on the same machine. The important point is, though, that we're running the same Power 6 chips from the bottom end to the top end of these machines. So they are 100% binary compatible. It is, after all, the same processor running the instructions. The Power 6 processor itself has a lot of mainframe inspired reliability built into the actual processor, And it also supports the virtualization, as they also have the same hypervisor technology in all machines. Now, the important point to note when we're looking at controlling our machines is that these mid-range and enterprise machines must come with something called a HMC, the Hardware Management Console. We'll look at this in more detail in a second. The entry-level machines can either be controlled by this HMC, or on an alternative we can use this IVM, Integrated Virtualization Manager. This provides the HMC functions in the first logical partition inside the actual machine. For the blades, we have the options of either IVM or no virtualization, so we just run the 2 or 4 CPUs as a single machine. The entry machines can also run in this mode. The HMC is purchased from IBM as a single-purpose dedicated appliance. In physical terms, it's either a desktop PC or an x86 server that you put into a rack. You either log on to the console and use it that way, or from a browser you can get to it and see exactly the same console. It runs a network to the service processors in the back of every single one of the machines. In the larger machines, there's 2 service processors for redundancy. This network is not to be used for any other purpose. A single HMC can be connected to up to 32 different machines. And it's quite common to have a pair of them so that we can do repair or fixing at one particular HMC and we can use the other one in the meantime. The HMCs actually will talk to each other and they'll remain in sync. The HMC is used for machine level functions like powering on and off the PowerBasics based machines. It can be used to update the firmware inside the machine. It monitors and reports problems on the main machines. In fact, it's the HMC that will dial back to IBM and inform IBM of any problems on the machine so we can action and engineer to bring a replacement part as soon as possible. When the CE arrives, they will also use the HMC to direct the service repair, get instructions from it, and to switch the machine into particular modes of operation so that they can withdraw hardware. Once the PowerBasics machine is up, we can do things like controlling our logical partitions, creating them, allocating resources to them, starting and stopping logical partitions, and dynamically changing them as the operating systems are actually running. Now let's look at these 4 technologies in the order in which they were introduced. Logical partitions came in with Power 4. This allows us to take a large machine and with the HMC request that it is broken up into several pieces and each of those runs as a separate machine with its own operating systems, applications and resources. We can allocate a whole CPU to a logical partition, a piece of memory in a fairly small size. The actual size depends on how much memory is actually in the machine. And we can allocate particular I/O or adapter slots. Each of the resources can be independently allocated, so we can say we want 3 CPUs and half of the memory in the machine and these 10 slots over here. We don't have any tying between the hardware resources. In fact, when we say we want 10 CPUs, the hypervisor will actually decide which 10 CPUs we're actually allocated. We just say how many and the hypervisor works out the details. And in these early days we could run AIX or Linux for power. Slightly later we introduced dynamic logical partitions. This is the moving of resources between logical partitions while they are actually running. So we don't have any outage when we want to make a change. This actually happens very rapidly. For CPUs, it's just a couple of seconds. For memory, it takes a little bit longer if we have to take the memory out of a running logical partition, as we have to give it time to page out that memory. For example here, perhaps our production machine is going through a large peak in workload, and so we could move 2 of the CPUs from logical partition 4 to it, maybe a couple of gigabytes of memory from logical partition 2, and we could move a couple of Ethernet adapters from logical partition 3. Bring those online into logical partition 1, let it work through this particular peak, and then we can move them back. Now in 2005, the Power 5 processor arrived with some exciting new technology. We can still use CPUs in a dedicated mode inside logical partitions, but we have a new shared processor pool feature. Here we can allocate processor time for a logical partition, but in fractions of a CPU. When we allocate this time, it is a guaranteed entitlement of that logical partition, and nothing that the other logical partitions can do can stop them getting that entitlement. If, however, a logical partition doesn't use all its allocated CPU time, it yields the processor back to the pool. When a logical partition is busy, it can then ask for those CPU cycles that are not being consumed by other logical partitions and get a good performance boost. The hypervisor is actually actively involved with this, giving the CPU time on demand, and it does this every few milliseconds. There are some other things like capped and uncapped high and low weights and virtual CPU number that we'll look into in later movies. Now you might worry that if a CPU is running multiple logical partitions, that there could be some security issues here. But no, this has been very carefully thought out, and we've actually achieved the CAP EAL4 Plus certification running in this mode, so it is still a very highly secure environment. Also with Power 5, we have this concept of a virtual I/O server. We can still allocate I/O slots to particular logical partitions, but we have an extra feature here with the virtual I/O server, so we can give the virtual I/O server as a logical partition particular adapters, but it can then make those available to logical partitions in a virtual mode. The communication is actually over memory inside the machine, so it's super quick. But it means that we no longer have to buy adapters for small partitions. We can share the adapters in the virtual I/O server. This greatly reduces the cost of our machine, and the setup time is also reduced because we can just allocate virtual resources without having to buy and plug in and configure real adapters, and this makes the machine very much more flexible. And finally, when the Power 6 systems were introduced, there's even more virtualization and logical partition technology. There's a list of some of them here. Many of these already have a movie covering them in detail, and probably some more movies to come.